Hello again and welcome back to the project. This week in the project we're going to do our analysis phase of the work. And I think that this is going to be actually relatively simple, especially compared to last week where we had to do a lot of different exploration and reading of metadata and work. This week it's mostly just going to be some geoprocessing tools. This is the stuff we already know how to do, and that unless we run into some errors, it's going to be a little more sort of, the time frame is predetermined almost. It's easy enough to do. So let's think for a second about what the best approach to finding out what agriculture in our land use layer is occurring in floodplains. Now, I'm thinking that I'll probably want to use, I could do something like a spatial join, but the spatial join doesn't really give me a good summary of it. So I'm thinking that probably what I'll do is a tabulate area. And before I do that though, if I really want this to be a good summary, I'll probably do a dissolve of the floodplains first. For this analysis, I'm not super concerned about which floodplains it's all occurring in. I just want to know how much of each type of agriculture is occurring in the floodplain. So I'm thinking that my workflow looks something like a dissolve floodplains and then a tabulate area at a sufficiently high cell size for the raster conversion, and then get our results. So let's dive in. Let's start out with our dissolve. Go to generalization in the data management tools. I'll go to input features. And actually before I do this, let's set my geoprocessing environment so that I finally set my workspace here to the default geodatabase that I created for this project last week. So I'll put it Scratch and then that. And I'll set this to my Scratch workspace too. So set that, and then now I'll go to dissolve, and I'll select my input features of the floodplains, and I'll let it keep the default name, and I don't want to dissolve on any value. I'm just going to dissolve. And it can create multi-part features, so that's perfect. I'll need to do that since there will be several distinct segments of features here. And throughout the work that I'm showing you right now, and if you end up doing this yourself too, I want you to be thinking about the limitations of the analysis workflow I'm doing on our final results. Think about the implications of exactly what the tabulate area tool does on what we get out of it. Specifically that it converts to raster before it does the tabulate area. And then if you're interested, think about some other workflows that might get us the same answers, or even if it's roundabout, just consider some different ways that you could work around those problems. That's the kind of skill we're trying to teach in this class, is getting you to think about the multiple ways you can approach these geospatial problems, both so that you can work around problems when they occur, but also so that you can work around the limitations of a particular analysis, the issues that it might create in your final result, and if that's unacceptable, that you can think of another way to handle it. Okay, so we got our floodplains back. Turn off the original, and let's turn off the land use for a moment. And there's our dissolved floodplains, and let's confirm it is in fact one feature class, so that's perfect. And then let's try out a tabulate area. We won't have high expectations for this. I'll still put it in my Scratch workspace, but I'll use the tabulate area tool to calculate cross-tabulated areas between the two data sets, and I'll provide my input raster or feature zone data as the floodplains dissolve, and we'll use object ID. It doesn't really matter which one it is, and then because there's only one record. And then the feature class data is the class data, feature class data is our land use in the study area. And the class field I'm interested in right now is class 1, which holds the main class. Now, one thing to think about here is that we're just getting back the major class here. If we wanted to get back the major and minor class, we might want to do something like a field calculation. So let's actually go ahead and do that. We'll run it this way. And so I'm going to go to the land use layer, and let's add a field here. And I'm going to make it a text class field since we have class 1 as text. So I'll call it combined class. And what I'm going to do is merge these two fields here into one, and that way we can get the full breakout. If you don't need it, then you could just do class. But if I want to know class and subclass for a future lookup, then we'd want to merge them. So I'll go to text. I'll set the length to 10 to be short but reasonably long. And then I'll do field calculator. And I'm going to switch to Python so you get used to that syntax. And what we're going to set it to is class 1. So I'll make a string in quotes. And in Python, the way we would concatenate or combine two values is with those kinds of brackets. And so it's open and then close. And then I'm going to do space and then open and close again. And I'll do .format, which is the function that then passes these values that we have here into the string. So this is kind of backwards looking, but what we're saying is this is a placeholder and this is a placeholder. Put this value here into the first placeholder and this value here into the second placeholder. Oop, and I selected the wrong value here. So put this value here into the second placeholder with a space in between. Now I'm also going to try to correct that space problem we had. If you remember how the Z class was padded with a space in front, so we need to remove the spaces before or after if they're occurring anywhere in there within the classification fields, because none of the ones should currently have spaces. So what I'm going to do is this, and I'll put in quotes a space here and then a comma and say replace it with quotes no space. So basically this says replace any spaces with no spaces in this value here. And I'll do the same thing to the other one. Okay, so now we have this complex, kind of weird looking calculation here. They're not always this weird looking, so don't be too turned off. But again, we have a placeholder, and what's going to be put in that placeholder by the format function here is this value here. And the result of this value is taking the value of the field class 1 in any given row and replacing spaces with nothing. And then we're going to take the second value that we're going to place in here, and before we do, we replace spaces with nothing in that second value again, and then replace that value here with just a space in between them. The reason why I'm doing this, if you're not remembering, is that we had some problems with having extra spaces leading in front of our classes and in front of our subclasses before. So what I'm trying to do is make sure that we correct the data as we are turning it into one field here. So I'll click OK. Okay, and so far it looks good. And this will let us run tabulate area and get kind of this cross-tabulated combined class rather than just the single class here. Because since they're in separate fields, we can't do it on multiple fields. So we'll just, this field here, or this record here, we have class D subclass 8, and now we have D space 8 that we can use for our cross-tabulation. So let's bring up tabulate area again. And again, floodplains are our feature data, and our class data, the layer that has the classification on it, is our land use in study area. And the field now is combined class. And just because I'm not sure if I'll like it yet, I'm going to call it floodplain, or floodplain agriculture tabulation in my Scratch geodatabase still. And this cell size is in the coordinate system of the data frame. So I think that we're looking at a kind of a modest cell size here, but let's give it a try at first and see how it goes. Okay, so let's take a look at the result. Open that table, and we get sort of a weird thing here, but for the record, we just get tabulations going up into all of these names, and it looks like the areas must be in decimal degrees, and I bet that we're getting some weirdness related to the cell sizes. So let's project the data sets and try it again. And I'll go fast through this since you know how to project data sets here. So And in this case, I'll use California's custom projection since that fits this data best, but you should use in your own work whatever projection works most for you. And I know it's called Teal Albers. Floodplains dissolved teal. And while that's going, I'll set up the next one. Okay, and our reprojected data. And let's just make this a little faster by setting our data frame to the same projection now so that it all renders more quickly, since it won't reproject on the fly. And there we go. Okay, now let's try our tabulate area again in units that we actually understand, and we can set a higher cell size too. So actually we'll run it from scratch so we can get the defaults filled in again. So we're going to use floodplains dissolved teal as our input. We're going to use the land use dissolved teal for our class. We'll use our combined class field again, and I'll call it tabulated floodplain agriculture. And that's the cell size it was giving us, more or less, in decimal degrees. So I would assume that lots of these things weren't getting picked up in the raster, because remember, we're converting all these small polygons to raster cells. But if those raster cells are over a kilometer, that's 1.3 kilometers, then we're missing a ton of this data here. So let's do a much smaller cell size here. Let's do this at 20 meters. I'd like to do it at 10, but I don't want it to take forever. So I'll run it at 20 meters and we'll speed up the video while it's running. Okay, so our results are back. Let's take a look and close that. And looks like our data table has numbers that make a lot more sense, even if the field headers are still a little confusing. We have a better spread of values from small to big. But it's definitely still hard to take this data and make true sense of it because of the way that we have the field headers structured. So an alternative way to go about this would be to create a new data table that we use as a lookup for this instead, and make our field headers have the names of the classes. So let's create a data table, and I'll call it land use lookup, and keep the defaults for the rest of this. And we'll have a class code, which is the thing that we have as the headers right now, and then the name, which we'll pull directly out of the metadata in the PDF. So I won't create it right now, but that's what I would do in the case that we really want to understand what's in the headers. And we'd put the combined class into the data table in the class code field, and then in the name field I'd put the value that corresponds to. So it might be like there was like G3 being wheat or something like that. So G space 3, that class code would go in the class code field, and then wheat would go in the name field. At that point, I could join it on to the end of this table with the combined class field joining to the class code field in the other table, and then have the actual text be attached to this table instead of just the class code, and then it would show up in these field headers when I run tabulate area, as long as I selected that new name field as the class field to use. Okay, now we still have a few things to think about. That even that method wouldn't be particularly perfect because we have a gap right in here in our data. And it's not just that this was filtered out by us when we ran our filtering, it's that that data is actually missing. And there's pretty significant agriculture going on, especially in here, because that's very fertile land. And so we're missing some important data that could heavily skew our results. And that's something we definitely need to pay attention to as we're dealing with our data. We're also missing some floodplain data up here, and that could skew our results as well. It might be that those areas don't particularly matter for the analysis, or they do. It depends on how we define our problem. We may need to go fill in that data by finding alternative sources or proxy sources of information, Or maybe we skip it and figure that this is a good enough sample of the data and we scale our results accordingly. It's all about how we define the problem. That's what says whether or not we need to go back and fill in these gaps. We don't have a particular project set up here that really provides our scope for us. We don't have an end result in mind other than just developing geospatial skills. But having that problem defined would guide us into whether or not we need to go get the rest of that data or a proxy source. The other issue we potentially have is cell size. So the cell size we chose can be great and it's very refined, but we need to pay attention to it because how that data got rasterized for tabulate area definitely affects the results that come out of it and which features get picked up and which ones get lost. So that's something that really matters for our data quality and data integrity on the output. When we're looking at all these fields, it could be that some of them are small simply because they didn't have enough cells captured, and some of them are big because they were overrepresented, and our choice of cell size can really impact that. One last thing that I won't do today, but that I think could be useful, is if we actually ran the tabulate area in reverse, using the floodplains as the class data and the land use as the zone data instead, and that way we get the zones as columns and the land use classifications as columns and the area in a column as well, which is much more usable format as far as we're used to. We'll maybe pick that up next week and do that before we finish off all of the data. Okay, that's it for this week. In this week's portion of the project, we ran through the major analysis steps and ran the dissolve tools and tabulate area. In the process, we dealt with some data quality issues using the field calculator. I hope you see that this isn't always a linear process. You're seeing my mind jump around a little bit as it tries to solve this problem. That's expected, and I'm leaving it in the video intentionally so that you could see that that's very normal when you go through a similar process. These problem-solving steps occur because it's really impossible to lay out exactly the start to finish at the very beginning. I kind of knew I'd probably be using tabulate area once I got the data all set up, but I didn't know what the data setup would require until I found the data. As I said, next week when we pick up the project again, we're going to try the tabulate area reversing our inputs so that we have columns coming out instead of a single big row with a lot of different columns, or we'll have a lot of rows for each land use type. And then we'll wrap everything up with a map and metadata as well. For the rest of this week, think about what would be good to keep in the metadata, as well as anything that should go on the map. See you next week.